Hello to all, welcome to the channel GeoGuru. In this video we are going to perform a supervised classification and in Google Earth Engine. The advantage of Google Earth Engine and doing supervised classification or preparing any classification map is that you can change your training data sets on the fly, that you no need to download the satellite data set, you don't need to download the other stuff like training sites and other. You just need to update it once in a while and you can update your classification with more prominent manner. So let's begin. So for this exercise purpose we have imported our data set. So the first data set is our administrative boundary. So we have used the FOAO GAUL administrative boundary for the Bhopal district, or otherwise you can import your own shape file either through assets, or if in fact you can create your own bounding box by using any of these buttons. Next thing that we have used is the Sentinel-2 data. So Sentinel-2 is an optical satellite data high resolution data set freely available in the Google Earth Engine. You can see the band combination of Sentinel-2 surface reflectance by searching the Copernicus SR2. So in this segment you can see there are total number of these are the total number of bands. For example, B1 is aerosol, B2, B3, B5, and for red edge band there are B5, B6, B7. So for the classification purpose we are going to use all the bands from B1 to B12. So that is why after importing, first of all we filter the only those images which has a cloud percentage less than 30. Then we have filtered the data set from January 2020 to December 2020, that means the 1st of January 2021. Then we have select all the band starting with the B. Either we can use this line or you can manually write this, select B1, B2, B3 up to B12. And after that we have filter our image only for the specific AY, that means with this particular administrative boundary. Then we have taken the median value of entire tenure, the entire day duration we have given, and we have clipped with our area of interest. After that, this is the visualization parameter. So we are visualizing in the false color composite NIR band, red band and green band. After that, with this line we are actually visualizing our Sentinel-2 layer over our map. So I'll just click hit run and let's see what type of data is visualized. So we have taken the Bhopal district in Madhya Pradesh state of India, and this is the whole district boundary. And as you can see that the Sentinel-2 data set have been visualized with a false color composite, and this particular image we have selected only the 12 bands, that means B1, B2 up to B12. So the next task is to create the training sites. So in order to create the training site, first of all we have to identify the number of classes that we are going to use. So in this case we are going to use only 4 classes, that means water body, urban, agriculture and others. So for that purpose we have either you can create the training sites with the help of a polygon, or you can create with the help of the point. So I'm just in this case I'm creating the points. So we have to click over this add a marker and we go to the geometry. Then we have to give the name, suppose water, then it will be imported as feature collection, and we have to add the property. So the property will be like land cover and the value will be 0. So that means all the water body will have the value 0 in their attribute table. Just click OK, and after that you can just change the color so that water can be displayed in the blue color. Okay, and afterward just click over this this water and you can add the point marker over the specified class. So I'm just deciding the water body, so I just had to click over here. So this is the training sample created. This is also water body, this is also water body. So you can take n number of samples according to your area of interest or the extent of your area. Okay, and you can take the reference of the Google satellite image also. Just you have to go to the satellite, and if you are confused, this like in the FCC color, this road might be display as a black color, because urban class also absorbed all the radiation, so it maybe look like a water body. So you can actually cross check with the Google satellite image. Yes, so with this I can see that it is not a water body, but it is a road. So likewise this you can create the number of samples of the water body. Now the next thing, I want to create the sample for the suppose urban class or the built up. So for that purpose I have to click this new layer, and I just have to, so there are two layers, one is water and other is geometry. I just have to click this gear icon. Now this is, I am giving the name urban feature collection, click property plus. So please remember, please make sure that the name of the property will be same as in the water body, like land cover, and the value should be different. So in this case I'm just giving 1. Okay, I just need to change the color also, like usually the urban class is shown in the red color. Okay, now I have to point the mark for the urban class, like this is the built up area, this is all the built up area. After that I want to create a third class known as green. Okay, so I just click on new layer, click on geometry icon. Okay, so with the name green feature collection, it should be the same as previous one, that is land cover, and the value will be different, like 2. Okay, so here I'm going to define the green, like this class I have taken into account of forest and the agriculture. So most of the portion that are in the FCC coming as a red color should be the green. So like this portion, or this marshy land, okay, and this one, or if you go to the suburbs of the area, you can find the agriculture field also, like this. Okay, so presently I'm not creating many 2 elements, so just for the training purpose. So then in the last I'm just going to create a new layer, geometry, and in this I'm going to give other class, or you can give anything you want, feature collection property. The name of the property should be same as land cover. Okay, now value should be 3, different from all others. Okay, now this will be in the yellow color. So all the remaining sites like barren area or the other open field which had not been encountered in any other classes, you can give to them. So likewise when you are exploring the image, you came to know that now these are also area coming to the urban, or these are also area coming to the agriculture or the green. So what you can do, you just go to the suppose urban. Okay, so now when you click the point, it will be added in the urban. So you can see it is coming in the red color because urban are in the red color. Next, like I want to add the green portion, that means agriculture. So these are the agricultural land, so I can create that one. So you have to make sure that all the elements have a proper number of entries. For example, the water body has 5 elements, urban has 13, green has 11, and the other has only 3. So we need to create more for the other. So this is the forest area. Okay, you can create for the forest, and for the other you need to search for it, like few samples, so that it will be easy for the algorithm to classify. Click on others. So it is totally depend on the user, like for him or her it can be treated as a agriculture, urban, the forest. It's totally depend on your area. Suppose if you are working in the agriculture, you need to define the different type of crops. If you are specifically working in the urban, you can classify difference between the urban or the roads or the settlement, etc. Okay, so for now this purpose, for this training purpose, I'm just giving only these few elements as, and you can zoom out so you can see that this much of training sites we have given. And in order to make sure that all the upper portion should also have a proper classification, so we can provide some more training sites to this area, but as of now I'm just looking for this only. So next thing that we can do is combine this all the feature collection into a common. Then merge green, and lastly merge other. So in order to check, just give a print command of control points. So you can see a feature collection has been printed with the 41 elements, and it has two columns. One is land cover, and that's been an integer, and the system index. So you can check any of the feature, for example 15 number. Acha, go to the property, so it is the land cover 1, that means it is the land cover 1 means urban. And if I go downwards, if I click the 35 number, it is the land cover 3, that means it is the other. Next thing that we are gonna do is to overlay the point on the image to get the training data set. So for that purpose we are going to define a variable training is equal to image name. So here in this case our image name is s2 dot sample regions. Then in this brackets we are going to define first of all the collection, and here the collection is the control points. The next thing we are going to define the properties, and in this case the property name is land cover, that means the attribute table we have given in the properties, and as I told you it should be the common, so it should be in the a list. Okay, that means square bracket. After that scale, so we are using the sentinel data which has a 10 meter of spatial resolution. Then tile scale is to provide the computation allowance, the number of pixels it should compute. Okay, now in order to check that what this training sample region do, so just try to print this training and let's see what comes after this. So it is also printing a feature collection, and if I go to the features, so just open any of the feature, so it has total 13 properties, the 12 of which are coming from the band values. That means for this particular point over the map, these are the reflectance value of different bands, and these are the class value that we have provided. That means this is the 0 class number. So now we are what we are going to do, we are going to train the classifier. I'm just going to highlight this as a comment. Train a classifier, and for that purpose we are going to define a variable classifier is equal to EE classifier. So if you go to the docs and search for the classifier, so you can find different type of classifier, and these classifier is nothing but the algorithms for computing the supervised classification. Either you can use the maxent, decision tree, and the minimum distance, smile cart, and smile name bias. So as a Google Earth Engine keeps on adding some new type of algorithm and each and every updation process. So in this case I'm going to take the smile random forest. Okay, so either you can copy this. Okay, so just paste it over here. So this is the E classifier smile random forest. So the first thing that we have to define is the number of trees. So in this case we are going to define the number of trees as 50, and everything I'm not using anything. So now we have to train this, and for that we are going to use the train command, and in the brackets we have to define some parameters. So first parameter is features, and the feature is nothing but the training site. That means after the overlaying the point. Okay, and next thing is the class property, and here the class property is in inverted commas Landcover, and next thing is the input properties. So how you can identify that this type of parameter should be required? You can always go to the docs and search for train. So train is an function of the classifier, so you can go to this train, and in this train we can give the features, class property, input property, subsampling, etc. But all are the defaults, only the important features I'm going to give. So features are the training, class property is the Landcover, and input property is s2 dot band names, bracket close. Now all the necessary steps has been completed. First of all, we have overlay the point, then we have train our classifier. Now in the last step we are going to classify our image, and for that purpose we are going to define a new variable classified, and this will be the final image after the classification. So s2, that means our main image, dot classify, and in the bracket we are going to define the classifier, and just we are going to add as a by using map.add layer. So it will be the classified image. Okay, so we know that we are using the 4 class. So in the visualization parameter we are going to give 4 value, that means from minimum 0 to maximum 3. Okay, 0 1 2 3, and the palette, that means color palette, we are going to use as the 4 colors. So the first class is the water body, so we are going to use the blue. Then second class is urban, so it will be represented in the red, then green, and last is the other, so I'm just going to display in the brown color. And after that we are going to provide the name to the image, so it will be the LULC. And if I just hit run, and let's see what will be the result. So it is showing me error that s2 classify is not a function. Okay, so here the C is not capital but the small, as the JavaScript is the case sensitive. So now we can see this another layer of LULC is going to be added. You can uncheck all these parameters if you want. So now this is our image, that means a final classified image is overlaying in our map. So this is our final map. You can always increase or decrease the training data set. So suppose after the classification you encounter that yes, this class has been imported wrongly, that it should not be in for example, if I just zoom to this particular area, so here we can see the most of the portion are in the green color. And if I just recheck that, okay, if you don't find that this particular area, I must say like this portion should not be in the green color, or maybe should be in the open area or some other area, what you can do, you should just simply go to your particular class which you want to add. Suppose this is maybe you want to classify as the other, so just go to this and add some more random samples over here. Okay, and nothing, you have to do anything else in the code, just hit run once again. So what it will do, it will take these 4 more training data set and reclassify your image with some more accuracy or more authenticity. So in the last, if you want to export this image into your Google Drive, if you want to use this in any of the software, you can always use the search for the in the docs like export. If you get the like export image to drive, you just need to copy this line and you can use this function to export your data set. So like export image to drive, we have to define a curly bracket, and the first parameter you want to give is the image. So image is our classified image. Next thing, we have to give the description. That description means name of the image you want to save as. For example, I am just using LULC Bhopal. So folder name, if you define the folder name, it will be specifically saved in that particular folder in your Google Drive. Otherwise it will be saved into the root folder, and if there is no folder with this name, so the Earth Engine will create a separate folder with this name and your file will be saved accordingly. Okay, you don't need to give the file name, prefix, dimension. Okay, region is also very important thing, like for which region you want to save. So if you want to just save this particular area, not the whole region, you can define this particular area. Or if you want to save the whole region, just define the AOI or your shapefile. Next thing is the scale. So in this case, we are using the Sentinel data, which is a 10. Spatial resolution, CRS should be like, if you don't want to give, no, there is no problem. Otherwise you have to define like EPSG 436 or any other thing, and everything can be leave as it is, and you have to give the curly bracket close. And after you hit run, so this taskbar will be highlighted and it is asking you to save this LULC Bhopal image. You have to click run and you have to recheck that now it presently it is saving in the coordinate reference system EPSG 3857. You can change by writing down in the script. It is the scale, it is the folder. You just have to click run, and within a fraction of time, depending on your size of the image, it will save into your Google Drive and you can use for your own. So hope you like the video. If so, then please hit the like button, share this video with your colleagues and partners, and do subscribe to the channel. Thank you.